Hello everyone, I welcome you to our chemistry introduction, and in this video we'll be looking at the scientific method. So basically the scientific method is a set of procedures that scientists follow in order to gain knowledge or understand the world. So this scientific method that we're talking about differs according to which field of science you're talking about. It differs in psychology as to chemistry. So the type of scientific method that we'll be talking about in this video is under chemistry. And basically the scientific method has these 5 steps that you need to know. So as we've defined the scientific method, it's just a method that we use as scientists when we want to gain knowledge or explain something about the world. So the first thing that you need to do if you're trying to solve a problem using the scientific method is that you will need to carefully define the problem. What is the question? What are you trying to do? Let's say if your question was, how do I make water clean? That is your question and that is your problem. Once you state that question and you understand it, the next thing that you're going to do is come up with what we are calling an hypothesis. And an hypothesis is just basically you trying to come up with a solution or a suggestion on how you can clean water. So an example would be, let's say you'd say you can clean water and make it safe to drink if you boil it. That's number one. If you filter it, or if you filter it and boil it, you can make water clean. Okay, so that's sorry about that. That is what we're calling an hypothesis, a suggested solution to the problem that you're trying to solve. And once you've done that, you are going to perform experiments based on the hypothesis that you have come up with. So an experiment based on the example that we're talking about of purifying water would, let's say you'd say you boil water and you test it for bacteria or for any form of parasites. And another test would be you just filter the water without boiling it, and you try to see if the water has parasites or not. And the other test that you'd perform or experiment would be if you boil the water and filter it as well, and you try to see the outcome if that water would be safe for drinking. So once you do that, you perform experiments, you're going to interpret the results that you're going to get from the experiments, and that is if the water would be drinkable when you test it, if the water would still contain parasites and thus be unsafe for you to consume. So once you do that, you're going to summarize the information that you are going to get from the results into a concise law. For example, you would say if you boil water, the parasites or the bacteria in the water are going to die. So a law is just basically telling you what's going to happen when you do something. It doesn't explain why the bacteria die when you boil water, but it just tells you that every time you're going to boil water up to a certain degree, bacteria will die in that water. So that's a law. After you do that, you're going to find that some of the hypotheses that you came up with, like for example, you just say you are just going to filter the water. You find that if you just filter water, filtering doesn't kill bacteria in the water. Okay, it just removes the dirt, but the bacteria and the microorganisms still will survive in that water. So that hypothesis is not going to survive. That's where E comes in. The hypothesis that survive the many experimental validation tests evolve into theories. Okay, so the suggested solutions that you came up with at first, which we're calling as an hypothesis, if they survive at the end, you find that they are working in accordance with the law. These hypotheses will survive into what we're calling a theory. And a theory is different from a law in that a theory will try to explain why, if you boil water, the bacteria die. So the law is that if you boil water, the bacteria die. The theory would tell you that bacteria die when you boil water because they cannot survive in an environment that is above this certain temperature. That's why they die. So a theory just tries to explain why something happens the way it happens. Okay. So once you understand these few points, the next thing you would want to look at are the must know definitions under the scientific method. And these definitions are an hypothesis. You need to know what it is, and we're defining it as a tentative explanation of a set of observations. Okay, you observe something that, like for example, if you do this, this happens, and then you try to explain it. And usually, it's not all hypotheses that are true, some are false. If an hypothesis tends to be true, it will now evolve into what we're calling a theory. Okay, and a theory is a unifying principle that explains a body of facts. I'll end the definition there. Okay, it's a unifying principle that explains a body of facts. It's a fact that, for example, when you have anything, you hold anything above the ground and you let it go without any support, that object is going to fall to the ground. That's just a fact. And a theory is going to try to explain why, when you hold anything above the ground, when you let it go, it falls down. A theory will come in and try to explain that this body falls down because of its weight and the influence of the Earth's magnetic field on the object. Okay, so that's just a theory trying to explain why something falls down when you let it go. And one other important definition that you need to know is what we're calling a law. And the law is a concise verbal or mathematical statement, okay, of a relationship between phenomena that is always the same under the same conditions. What this means is that a law is a variable. It means it may be a statement or it may be a mathematical statement, an equation, like some of the equations that Einstein came up with. Okay, so you find that these are always the same under the same condition. It is a law that when you hold something above the ground and you let it go, it will fall to the ground. It's just a law, and we call it the law of gravity. A law doesn't try to explain why something happens. It just tells you that when you do this, this will happen. When you do this, this will happen. Okay. Then a theory comes in and tries to explain why that thing happens. I hope you understand the difference between a theory and a law. A law just tells you that, okay, when you kick a ball, this will happen, but it doesn't tell you why it happens. Okay. And a theory will try to explain why that thing happens. So that's the differences. So let's make sure, guys, that we understand these key definitions, because they do ask this in tests. They'll ask you to define what an hypothesis is, what a theory is, and what a law is. So after you know those, we can actually sum everything up into this diagrammatic representation of what the scientific method is. Find that in the scientific method you are making observations and coming up with an hypothesis. You do the experiment, and that will lead to a law. Okay, so many are the times that when you do the experiment again, you may come back and try to make other observations or come up with other hypotheses and try to see if you can make a law from that as well. So These are just basically the few things that you need to know when we talk about the scientific method, right? If we've understood that, I'm going to see you in the next video where we are going to learn about some more different concepts. Bye bye.